So let's take a peek at an ethane molecule. Here we go. Here's our friend ethane. Right now, it is in a conformation known as staggered. And here is ethane. One moment. There we go. Let's just get this arranged here. This is also ethane, but it is in the eclipse conformation. So here's the staggered conformation. It's giving me problems here. Hold on one second, everyone. Sorry about that. There we go. As you can see, these conformations are slightly different. Let me try to overlap them for you. Try to overlap them, you'll see pretty quickly, I think, they're not exactly the same. Now, one methyl, the methyl on my left, probably your right, are the same, but the methyl on the other side, my right, your left, is not the same. You can see they're different. Okay? Now, looking at them from the side perspective, you can't really see it. If, however, or you can see, but it's not simple. If, however, we were to rotate these, and instead of looking at the side of the molecule, look down the bond. Now, put that over here for now. Let's just hide that for now. Now, here we have the staggered conformation of ethane. I just turned it around to face the carbon atom, okay? I can rotate the bonds. Now I'm going to rotate the carbon closest to me. Here we go. Wait a second. There it is. Now watch this. I can turn the carbon closest to me. Okay? Now notice, it starts out in the staggered conformation. Let's do something interesting here. Let's select and let's make some color here so you can see it. Oops. Let's make this atom here. Let's make that blue. Okay? So now we're going to take the blue atom and now we're going to try to turn it, torsion. So watch the blue hydrogen. So now I turn it into eclipse. So now if you look at this hydrogen here and this blue hydrogen, you can see they're overlapping now. And if I simply turn it back the other way, you'll see that they're now not overlapping. In fact, they're about 60 degrees away from each other. And this will just keep doing it. Now, the limitation is going to be the limitation of my elbow and my shoulder. But if I could rotate my shoulder, it would just keep going. Okay? Like that. And now, the molecule, any single bond that has free rotation will keep doing that. It won't stop. It'll just keep going round and round and round. Now, let's take a look, first of all, at energies. It's not over there. One second. There we go. All right. So now, let me one second here. I'm still learning how to manipulate two molecules at once. So now, let's take a look at the two conformations of ethane. Here is the staggered conformation, where the blue hydrogen here and the white hydrogen over here are 180 degrees from each other. And let's look at the eclipse conformation. So here's the eclipse conformation, where now the hydrogen here, let's color it blue as well. There we go. So now here, this blue hydrogen here is 180 degrees from that white hydrogen over there, and about 60 or so degrees from these two. Okay. So now here, the blue hydrogen is overlapping this white hydrogen, so they're right on top of each other. Now let's take a look at these in a different way. Let's make them into space filling models. There we go. Now this is what's called a space filling model, or a van der Waals model. Now as you can see, the blue hydrogen seems to have a little bit more room in this model than in this one. In the eclipse version, you can see the blue hydrogen and the white hydrogen are just about, well, they are colliding with each other. They're in each other's way. Remember, these balls here, or partial balls, are representing the electron cloud. So the electrons from here and the electrons from here are in very close proximity. Whereas here, the electrons from the blue hydrogen and the white hydrogens here and here are as far apart as they can get. So this molecule, this conformation of ethane is what we call the low energy conformation. Okay? Ball and stick. This is the low energy conformation because the electron cloud from this blue hydrogen is as far away from the electron clouds from these white hydrogens as it can possibly be. This, the eclipse form, is a high energy conformation. Why? Because the electrons from this white hydrogen and the blue hydrogen are as close as they can be. So in terms of potential energy, this one is low and this one is high in potential energy. Okay? All right, so that's my quick introduction to conformations, eclipsed and staggered. We are going to do more, but I want to end this lesson right here because I don't want the lessons to be too long. And I want to wish you all good luck and good chemistry. We'll see you soon.